where we're at now is inverses. I thought that they weren't going to put this on the final, but they did, because that's where we should have ended the year at. So, we're going to kind of try and do our best on this section, because it's where we're supposed to be. The good thing is that it is an Algebra 1 review. So it is meant to be a little bit of an Algebra 1 review. And hopefully it feels that way, okay? All right, here we go. How can you find the inverse of a table? Want to guess? Anyone remembers? How do you find the inverses? You do the opposite in a sense, but all you're doing is you're going to switch your X and Y. You're going to switch your X and Y values. So to find the inverse, and then you're going to call the table inverse. So call the table inverse, you're going to label it as f to the negative 1, but it means the inverse of f. Okay. Switching the places. So here we go. Nope, just switch it. So negative 2 and 2 is going to become 2, negative 2. Negative 1 and 6 becomes 6 and negative 1. 0 and 10 become 10, 0. 1 and 14 becomes 14, 1. 2 and 18 becomes 18, 2. Ta-da! The inverse of the table. Literally just swap them. The fact that y'all didn't learn the Algebra 1 kind of is concerning me a little bit. I'm a little concerned. But we're going to keep pushing. You do? Okay. All right. Okay, so you're still with me? Now we're going to look at it from a table. Okay? It's just as easy. So on the table, you're going to choose key points. And switch their X and Y's. So you're going to choose key points and switch their X and Y values. So notice here, we're at, what is this? 6, negative 2. So instead of 6, negative 2, we're going to be at, that becomes negative 2, 6. So I'm going to go to negative 2 and go to 6. Okay, remember we had 2 and we were here at negative 6, right? So instead of 2, negative 6, it's going to become negative 6, 2. So I'm going to go to negative 6, go to 2. You're reflecting. We're going to talk about that. Let's choose, what's another one we can choose? Is 10 at like negative 6? Yeah. Let's do 10, negative 6, and it's going to become what? Negative 6, 10. So I'm going to go to negative 6, go up to 10. That's enough, right? You'll feel good about that? And we're going to connect them. And remember, these are the straightest lines you've ever seen. Bam. There's your inverse graphically. Okay? What it ends up happening is that it reflects over the imaginary line y equals x. So it should be a reflection. If you were to fold them in half along this line, they should reflect, again, me and my straight lines, guys. Me and my straight lines. Okay? How do you feel? Okay. The remaining part of this review will be posted. Remember, make your review sheet and be ready to go. Okay, so I'm back. We went through finding the inverse from a table, inverse from a graph. Now we're going to talk about finding an inverse of an equation. So again, hopefully this should feel like a little bit of an Algebra 1 review, but better review than assume. So when you're finding the inverse of an equation, the first thing you want to do is, 1, if it's f of x, you want to change f of x to y. Okay. Second thing you want to do is switch the x and y. Okay. The third thing you want to do is solve for y using inverse operations. Okay. And the fourth thing you want to do is rewrite y, the new y, as the inverse of x. Okay. So those are going to be steps we go through in my sentences. All right. So here we have f of x equals 4x minus 3. So we're going to rewrite it as y equals 4x minus 3. That's step one. Okay. Step two is we're going to switch the place of our x and our y. So instead of y equals, it becomes x equals 4y minus 3. Step three is to use inverse operations, and our goal is to get y by itself. So we want to get y by itself. So we're going to get y by itself. The first thing we're going to do is add our 3. So that gives us x plus 3 equals 4y. After we add our 3, we then are going to divide by 4. Okay, so now y is by itself. So now that y is by itself, then we're going to write, fourth and final, we're going to write y as the inverse. So we have the inverse of x equals x plus 3 over 4. And that's our function. Okay, that's simple. That's all you got to do. All right, now we're going to talk about how can you verify whether two functions are inverses using algebra, not graphing. Okay, and this goes back to us using our composition, so composing. So if the two functions, so the two functions being f of x and g of x, okay? If they are inverses, if f composed of g of x equals g composed of f of x, which equals x, then inverses. Okay? If not, if f composed of g of x does not equal g composed of f of x, then non-inverses. That's a horrible H. Then non-inverses, okay? All right, so let's do a couple examples of this. So for example, here we have a of x equals 4x squared, right? Now, I know you're probably like, well, miss, can I just not switch x and y and solve and see if it comes out to be the other one? In reality, you could, but we're going to verify algebraically. So the first thing you're going to do, we're going to do a composed of b of x, meaning I'm going to substitute b of x into a, and then we're going to do b composed of a of x, meaning I'm going to substitute a of x into b, okay? So it's going to be a composed of square root of x over 4. So everywhere there's an x, I'm going to put square root of x. So we have 4 parentheses square root of x over 4 squared. Okay, so notice here how when you square a square root, it's going to set it free, right? So we end up with 4, and we're going to square the square root, gives it x. Square 4 makes it 16, and we're left with 4x over 16, which equals x over 4. Okay, now we're going to do it on this side and see what happens. So now we have b composed of 4x squared So now looking at B, everywhere there's an x, we're going to put 4x squared. So we have the square root of 4x squared over 4. Okay, the square root of 4 is going to give us 2. Square root of x squared gives us x over 4. And 2x over 4 equals x over 2. Okay, notice how these two are not equal. So since this and this are not the same, then they are not inverses. Okay. All right, let's try this one. So now we have 4x squared, c of x equals 4x squared, d of x equals the square root of x over 4. Okay, so we're going to test it out. So we have c composed of d of x, and then we have d composed of c of x. I feel like I wrote too many. It just looks like I wrote too many. There we go. All right. So now d of x is, so we have c composed of the square root of x over 4. So I'm going to substitute that in. We have 4 parentheses square root of x over 4 squared. When you square the root, it's going to set everything in the root free. So we end up with 4 times x over 4, which equals numerator times whole number, 4x over 4, which equals x. Now we're going to do this side. So we have d composed of c of x. So c of x is 4x squared. We're going to substitute it in. So we have the square root of 4x squared over 4. Okay, I can see here on the inside that my 4 divided by 4 is 1. So I'm just left with the square root of x squared. Square root of x squared is x. Notice how they both are x. They're equal to each other. So then therefore, c of x and d of x are inverses. Okay. And that's your inverse check. All right, the last piece of our review is transformations. So we're going to go over our transformation properties really quick. So with transformation, remember when you have it all together, you have your a f of x minus c plus d. Okay, and each one plays a role, right? So remember we had h and k because we talked about absolute values in quadratic, and h and k represented their vertex. So h and k represents the vertex of our quadratic in our absolute value. So that's why we wrote them in h and k. But overall, for all functions, we can just stick to it being a, b, c, d. So it kind of helps us stay in order. So your d is going to be your vertical translation. So going up and down. If d is positive, you're going up. If d is negative, you're going down. And therefore, as far as the points on the table or on the graph, you know, to each y value, you would be adding or subtracting. Okay. Your f of x, your inside, your x plus c, your x minus c. Remember we talked about x's are liars. That's why they're x's. X's lie, okay? It looks like it's well, it is x plus c, and it makes you think, oh, I'm going to the right. But look at our function notation here. It's already x minus c. And the only way to turn this into a negative is that a positive, is that c had to be negative. So you're actually going to the left, which means that you're subtracting from your x values, okay? X minus c, horizontal translation to the right, which means that you're adding to your c to your x's. Okay, if you have a negative a or a negative value, that means that your negative a causes it to reflect over the x-axis. So you end up reflecting, which means you're multiplying your y values by a negative. If your x is negative, then it's a reflection over the y-axis, and you're multiplying your x's by a negative. I don't know if y'all can see my cursor. Your x is by a negative, sorry. And then a f of x. Oh, I forgot the b in there. He's a little funny. We haven't really used b, but sorry, I forgot the b. Your ABC. Let me just rewrite it all together, guys. That just looks horrible. Thought I could squeeze it in there. E x minus c. There we go. All right, your B, your A is your vertical stretch or compression. If the absolute value of A, I always say absolute value because we've already handled what it means when it's negative. So if the absolute value of A is greater than 1, then it's going to be a vertical stretch. If the absolute value of A is between 0 and 1, it's going to be a vertical compression. And what's happening is that you are multiplying your Y values by A, okay? B, F of B of X, that's going to be our horizontal compression and stretch. If the absolute value, and again, absolute value, because we've already dealt with if it's negative up here. If the absolute value of your B is greater than 1, it's a horizontal compression. I'm applying more pressure to the function. And then if your horizontal, if your B is between 0 and 1, the absolute value, it's a stretch. I'm releasing that pressure. It's going to kind of get wider. It's going to take a little longer, right? Okay, and remember, our x's are liars. So x's lie, so it looks like you're multiplying to the x values, but you're actually dividing, okay? You're actually dividing. All right. So let's look at some of our function notations and describe what's happening. So here, if we have a of x equals 2f of x, what variable are we given and what's happening? So we have the fact that this is going to be an A. So we know that A equals 2. Okay. So our A is greater than 1. It's not negative. So we know that we have a vertical stretch by a factor of 2. Of 2. Okay. Here, the variable that we're given is B. Our B equals 2. Okay. B applies to horizontal stretch compression. Our B is greater than 1. And so since our B is greater than 1, it is a horizontal compression by a factor of 2. Okay, here it says fx plus 2, f of x plus 2. So what am I telling the function to do? Well, I am telling the function that this is my c, and our c, it's a liar, so it's actually a negative. So I want to have a horizontal translation to the shift left by 2. Okay. Lastly, we have f of x plus 2. So this is a d. Our d is 2. So therefore, we have a vertical shift up by 2. Okay. This is pretty much a summary of everything that we should have learned this first semester of Pre-AP Algebra 2. Well, this is the ending because the other video had the other part. If you have any questions, comments, please let me know. Please make sure you're making your reference sheet for the final, and good luck.